that happens, you have to make a request again. So when it finds users with matching file, you can have replies being brought back to that particular client. So now Ella basically has what we call here no single point of failure. Of course, the moment when you start, that can be a problem, but the moment you have started, you have others that can handle that. So it means that it's less prone to denial of service because whom do you attack? Because it's decentralized. But of course, it cannot ensure that you have correct results, because if the files are saved in different locations, there might have been a few changes. So depending on the file you're looking for, unless it's locked, you can always have that problem of not knowing how to confirm or ensure the results are exactly the same. And from the diagram on the previous page, okay, previous slide, we have this issue here, okay, that can bring in an issue of congestion of the network. So one of the problems Gnutella has is network congestion, which can be a problem if depending on what network. So the protocol, of course, it's very simple. Okay, you simply have to notify peer of your existence. You get a reply of that. Okay, says a query for that, have a response. Okay, so push and request. The request server is behind the firewall to push a file out. So sometimes if it's behind the firewall, it might cause the server or request the server it out so that it's available and the other clients can be able to have access to that particular. The other one, P2P technology, we mentioned briefly before, but in detail, we have here is Kazaa. So basically, it's decentralized, just like it's a hybrid, okay? Centralized like Napster and decentralized like Gnutella. So you can see this can be an indication of centralized, okay? Where we are looking at, I'm trying to say, yes, these are examples of the servers, okay? And so what has to, that concept brings in the concept of a supernode, which acts as a local search. Each supernode acts as an abstract server for a small network. So we might be looking at this one here, for example, and then you have this one acting as a small server for that particular network. So this user upload the list of shared files on the superpeer, which is the supernode, and supernodes exchange list with the periodically with others. So the peer can send the query to the supernode, and that information that is gotten can be shared periodically with others. So basically, they end up sharing information about the new files that are there. Now, these new files, therefore, you can see they can easily be accessed by different clients. So this brings in that the Kazaa has an indexing and searching model that is not centralized like Napster and not decentralized like Morphos. Like Gnutella. So it's a amorphous kind of thing that has been a combination of that. So to ensure that some of the things are done, because there are times when you might have incomplete, it's very good for incomplete maybe downloads. So you are downloading something that it was not completed. This can be very useful. And sometimes you might want just have partial downloads, and that can also be useful. So the supernodes dynamically, okay, what will they do? They will, if sufficient bandwidth and processing power is there, they can be able to be electrically depending on the power. Remember, the supernodes perform a lot of tasks, hence they need slightly powerful. Okay, so and it will keep information about user registration, logs usage, bootstrapping of peer discovery, and so forth. So the supernodes become very, very useful in terms of this technology here. So maybe we might want to recap and see what are supernodes here, okay? So basically, any node that serves one of the network's relayers and proxy servers, okay? And it will basically be able to handle the data flow and connection to the users. So it has a semi-distributed architecture, which allows for excessive overhead at every node. And so the choice, one has to be careful to ensure that carefully chooses the files that you want to share, because the moment that is done, that becomes a problem, because you can see here, if files are personal, okay, or maybe financial information, okay, or which do not have maybe the rights to share that, let's say copyright files, then the moment they reach the supernode and they become accessible, the different kind of users. So in this case, supernodes, because of that particular power, one has to be very careful to ensure that that information is not accessible to this. Okay, so you can do that by restricting maybe those particular files so that they cannot be accessed. Okay, so that's one of the areas that one has to be very careful about when you're looking at these kind of files. Now, the other example of P2P technology is Freenet. This Freenet, basically this one is also has indexing and searching service, good for file downloading. And this is a platform for censorship-resistant communication and publishing. Now, so what does that mean? Anonymity, okay? And so it makes it very easy for the users, the clients, to be anonymous. Now, that is very, very dangerous, because it means that basically you have a lot of nodes discovering and then even trying to find out how to block them. Accessing certain file becomes an issue. So, so it's important that when you, this kind of technology has been a big problem, again, because of this aspect of being anonymous. So we'll see how this anonymity works in a short while. So this Freenet, okay, compared to others, you notice that Napster, okay, Napster, Kazaa, and Gnutella don't provide it. Okay, so what it means that peers know each other, but with Freenet you don't know the peers, so it's impossible to know if the user is initiating or forwarding a query. And now, because of that, you might not know if the user is trying to attack or you don't know. So it becomes a big problem when this technology is being used. So it's impossible to know the user is consuming or forwarding data. So answers a smart query. Data flows in reverse paths of the query of the originator peer, so it can be taken back to where it came from. So this technology has been there because of the problems that was from the others. Okay, because just like the darknet, most of the people will want, some of these files people will want to remain anonymous. So let's see how Freenet works. It basically uses the concept of being loosely structured. File placements are best things that when there's a file search that starts. So you see it starts from there, and then when it comes back, okay, to that point. So remember, the blue that is there on the original file shows a data request. The green is a data reply, and the request failed. So when it reaches B again, it will go to this one here, and then come back here, and then comes back here. Now you notice the files are going, the messages are going back as the way they were sent. So and 3 came back. Okay, and now you see we have here 6 was here, and then we have 7 here. 5 was here. So if you notice, they messed back where it came from, and then finally when it reaches this point here, you notice B, F, and E. So the only file that was still node that was not checked is D, okay? And so now you send a message to D. Now the message can now go backwards, back to the start, 11, 11, and then we have 12. Okay, so the follows the request comes back to where it came from, so a node can be able to be aware that that particular node does not particular file. The next one, P2P technology is BitTorrent. This one is one of the many forms, and this among the first started in 2001. And what we had seen before, it has an estimated percentage of about 43% BitTorrent views that are used to just variations of BitTorrent. Most are structured P2P. So you remember in structured, we were saying that it does not use a fixed kind of structure. So it's arbitrary, okay? And it usually has a centralized tracker which tracks which clients have which information, and that information can be brought back. Most of the clients have started now to implement distributed hash tables that we talked about last week to be able to help in terms of tracking, accessing those particular files. So BitTorrent, okay, from what we have there, it has an overlay structure, okay? It has an overlay structure that is placed on top of the existing network infrastructure. And then the peers can be able to download the files. And one of the issues there that the resources are not optimized for fairness. They're not optimized, and fairness is a concern. Okay, so it means some of the nodes might easily be served quickly. Why? In terms of this, because this means there's a better way to be able to connect on the different peers, and that means that the downloads can be much more efficient. But without using the distributed hash tables, that cannot be easy to implement using the trackers. When new files are added, okay, small data requests are carried using TCP connections to different machines in order to share that load of the initial server. And the trackers assist in communication between the pairs. And like I said, the concept of distributed hash tables will remove the trackers. So the original set of the BitTorrent was using trackers, but now most have been that are now trying to implement the variations that are trying to implement distributed hash tables are now much more robust. So the original part of BitTorrent will have this. So we have this one here, which basically will be a tracker. You can see it has a connection to that, trying to find all those different files. And then we have the client software who can be able to receive multiple pieces of information, knowing how much it can be processed. So the tracker maintains information about the clients using each torrent, and then the tracker identifies the network location of each client, either uploading or downloading to the P2P that are associated with that torrent. So now, but you see what we are saying now with the implementation of distributed hash tables, this now has been changed because the hash tables will be how store information about the location of the file. So this brings us to the end of the examples that I've used, and there are several other examples we didn't talk about of P2P technologies, and we have these ones coming up continuously. So this gives us a few important points. Some of them are basically the architectures that we talked about from last week, the topologies that are there, whether they're centralized or decentralized, those are key important points. So whenever you think about any of these P2P technologies, the key is to think about, to consider what are maybe the structure that it is using, and then you can be able to understand and maybe compare how it will behave in terms of implementation. So, I would like to field maybe one or two questions, if there is any, before we look at one of the new implementation developments of P2P technologies that has IBM. So any question or something that you might need to fill up at the moment? Okay, so so let's maybe tackle something new, and then maybe we'll field questions later on. So now, these P2P technologies, remember most of it from what we have discussed was about sharing files, trying to access and downloading music files. But can this be improved to be able to help in terms of businesses? Yes, it's possible. And so this is some of the newer developments. And this was started by IBM led in the WebSphere application server, which is basically a web application server. And this led to the implementation of an enterprise bus, okay, which is based on service-oriented architecture, and then finally the IBM integration bus. And this has been now applied in terms of businesses. So for example, if you do not have enough resources to be able to set up maybe servers and so forth, you might have this implemented, and that means you can reduce your costs considerably. So let's think about, let's see some of the applications, okay? So now, when you have a business, of course, one of the issues that you want to think about, critical issues in starting new and all applications. That's one of the areas, processes and services. And so you want to do that in the most cost effective. Now, so reliable connectivity becomes an issue, but when you have additional programming being added, verifying that the exchange of information is being done becomes an issue. Okay, so this means that in this ever-increasing IT complexity, the ability to be able to develop, to develop along with the minimal cost and maintenance becomes an issue that has to be considered. So what is the most reliable, okay, innovative and most reliable way to do this? So one of them is using service-oriented architecture to respond to some of these faster to new business opportunities. So the time we'll spend trying to add new technologies, this concept is easier. Move towards a service-oriented architecture. It means that an organization who needs a connectivity solution that can enable it to be seamlessly, reliably, and even securely be connected to different devices. So imagine a scenario where you have some of your clients on different sensors or different devices, different application servers. So these service-oriented business issues become things that you need to consider. And this, with the technology moving very fast, you need to do this very fast. Okay, so therefore, this service-oriented architecture, okay, is one that will have the business logic of the organization, including the enterprise data, to be provided as fast as possible. So you need therefore, in this case, you need an architecture that is flexible and responsive to the needs that you have at that moment. Therefore, this concept here, the thought of this brought in a new development, and that is where now enterprise service bus comes in. So the core principle here is enterprise service bus architecture pattern, and currently we refer to that as an IBM integration bus, but it's a successor to the WebSphere application server. So what we have here, we have a request that a service is requested here, and then there's a service provider. And in between here, we have what we have enterprise service bus, which basically connects the requester to the provider. So it provides service virtualization. Okay, so the behaviors of the component of that service-oriented architecture can be available to the service requester through the enterprise service bus from the provider. Okay, so it therefore will have intelligent processing of service requests and service responses, events, and messages that the different requests can have. So this now means that you can easily be able to you combine your all maybe some of your all files, and then you can be able to have them applied to newer technologies. And so this means that your organization can move. I mean, the services you provide can be can adapt to the latest technology as fast as possible. So you can see this is a very flexible infrastructure that integrates applications. So it will match matches and rules communication. Okay, it converts between different protocols. So now you remember from a distributed environment, we have mentioned that we are all operating at different architectures depending on what we like. So this converts those different architectures. We talked from our data communication, computer organization, we have different architectures, okay? So that means that it will have to transform and of course identifies and distributes business events. So this becomes very easy in the sense that you can easily be able to have from one side here, okay, having your businesses, and then you have through the enterprise service bus, you can have maybe your clients on the other side of different different devices that you are being utilized, okay, are being connected to also different devices that the clients or you also are using. So this means that this is done through the enterprise bus. Okay, so this is the enterprise bus will be able to do these conversions very nicely without necessarily having to invest and for an upcoming business that might be help on and bring down the cost. So the enterprise bus, therefore, enables integration between loosely coupled applications and services within their organization and services across. So we have a services-oriented architecture that is composed of granular architecture. So you send messages through the enterprise service bus, and event-driven architecture that can generate and consume messages anonymously. So this enterprise bus, you can see service-oriented architecture, message-driven architecture, event-driven architecture, all being handled through the enterprise service bus. And this one means that we have we are dealing with different platforms, different program models, and different messaging standards. So this enables simple integration across those different platforms. Okay, so from what we have discussed in terms of distributed environment, you can see this is now handling some of the issues we talked about earlier on, but using the enterprise bus. Enterprise service bus. we'll see what are the components, some of the things that are there inside that enterprise bus in a short. So this bus, therefore, okay, why an ESB help your connectivity? So basically, it allows you to be able to reduce the number, size, and complexity of the interfaces. Okay, it will reduce the cost and risk that is involved in business changes and new opportunities, and when new opportunities arise. So cost effective, because you don't be able to employ different, you have to incur costs trying to upgrade your technologies. Okay, promotes data and business logic, most usable and application easier to be to enable this to continue, because the enterprise bus will take care of those differences in data, differences in technology, differences in architectures. And this is dynamic, really time, okay? Event-driven service architecture. So replacing a responsive the serve back man hours to be able to move maybe your technology to maybe latest implementations. So help in your connectivity needs, of course, reliable and secure data movement anywhere in the enterprise. So how being tasks? Remember, one of the things we talked about when we started with the distributed system, we said, especially when we're talking about remote procedure code, we say that we trying to program based on network programming and socket programming is complex. You're meant to handle. So, and then of course, dedicated environment, common tooling. So tools that are there are common. Management is done in a very specific way, and operational support comes from that environment. This means that your connectivity issues are less compared to a scenario where you do this manually to set up those environments. Now, earlier on, I mentioned about the way this is structured. We have two possibilities: loose coupling and then tighter coupling. So now, when we talk about loose coupling, remember, this requires greater investment. So I will explain that in a short while. But basically, under loose coupling, you're saying more design work and more implementation work. Okay? Because what we are saying here, if you want them loosely coupled, then you is the environment you have to be able to link very easily to the wider network. Okay, so if you go for tighter coupling, it costs more over time, because tighter coupling means that you have to synchronize multiple organizations on change. You have to adapt, redeploy updated components. Because remember, tighter coupling means that if there's any change on the components, you have to change your components. Now, loose coupling on a way is about abstraction. From what we have discussed, abstraction means you're looking at it at a higher level, so you give it an opportunity for different components to plug in. But when it comes to tighter coupling, it means that you have to be kind of drill down to more specific issues, and that's why we are saying it can be hard, it can be expensive, it can be impossible. So different parts of the solution are difficult to manage separately, hard to scale, hard to distribute, hard to replace. Okay, more coupling implies more expensive because you have to keep on testing different components. So loose coupling requires greater investment, yes, but in terms, upfront, okay, upfront. Okay, because what is happening is that you potentially which are the different components that can plug in, and then you consider that as opposed to looking at one by one. So you're looking at them make sense, and so takes more time, but in the long run is much cost effective. When I talked about the enterprise parks, I think so. So let's try to look at it in this way here. So remember some of the things we talked about. Okay, so various platforms and devices and protocols. So this is okay. Let me have this one here. So you can see this is our enterprise bus. Okay, so connecting us to various platforms. Okay, so we have various platforms here. Okay, sensors, phones, RFIDs, HTTP, WebSphere, desktops, and whatever. Okay, and then we also have various programming languages, and further on we also have various data formats. So you can see each of those different devices maybe have on different platforms, different programming languages, different data formats. Okay, all these ones here will have the enterprise service bus, and therefore they make it easier for you. Okay, remember what you have said, loose coupling, and then of course from there it's possible now for you to have several models, programming models coming up, and several delivery modes. Okay, so through the enterprise bus, you can be able to plug in any of these. And so this can help you handle the complexity of an organized IT infrastructure by just implementing the enterprise bus. So how is this enterprise bus connected? So we can have look at what the structure we have here. So we can, for example, we have the development of the services, integrated environment design and creation of that, and then we have IT maybe management services here. And then in the middle here, we have the enterprise bus, which enable interconnectivity between the services. So we have different services, integration services. Maybe let me use this one here so it's clear. Integration services, information services are there. And then, of course, across that, we can have partner services, business applications, and then access to those different services. So, and then, of course, this one is lying on top of the infrastructure, which is availability, optimizes throughput and availability and performance of your enterprise. So this implementation here, okay, this implementation here under IBM, and basically it has made it easier for some organizations to easily be able to move up in terms of implementing new services as fast as possible. So if one is thinking about some new service, it can be very easy for one to be able to simply pick up that particular service, and then be able to provide this service to the different clients. Okay, so I think that brings me to the end of that part. So I think I can field questions in regard to this. Okay, any specific questions on this before I address some questions that are not directly related to this? Okay. Now, one of things that maybe before I answer the question by who is this? Oh, okay, Isaac. Okay. So before I answer that question, some of the things that I have put up here is the point of trying to expand the knowledge in terms of some of these areas. So when we began the course, I mentioned that we usually have discussions to be able to internalize. And so that's why in this case I set up tutorials, but I wanted to give, so the first tutorials are the ones that we'll have maybe because the later ones I might have to think about providing some solutions. But the first ones, no, because these are things that you can research. But this is different because some people are asking us if that is the assignment. No, it's not. It's not the assignment. This is just to ensure that basically what we have learned, can someone be able to pick up and find ways? And then, of course, like I said, I'm available to give comments and guides to some of the areas and maybe some reading material to make it easier for us to understand as we troubleshoot. So yes, Isaac, on e-learning, actually I've put a date and then extended. So that part I had given because that was the first, it was coming from the first one. So when we start this course, usually the first part, people have issues with the terminologies and that we use. So that one I have given, that extension is there. So it's on e-learning. I don't change words at the moment I've put and I've set it. So Isaac, you can check that out. It's there. So if it's not, just confirm to me I set it up, but it's already there. Now, the other thing is that now that we have finished this particular one course, this particular topic, again, I will set up the other tutorial maybe tomorrow, and again, I will give it for that. So feel free to be able again to check it out and then respond to it so that we understand this. And share questions. There's nothing that prevents people to discuss. If we set it up, we can discuss. But the key is that when you hand in, make sure that it's individual, so that we don't get into issues of plagiarism, which is not. And that's why even the credit that I'm giving is not much, but it's something that just to ensure that people are getting involved in what is happening. So otherwise, I think what I want to do is that if there are no specific questions, I don't want to start a new topic. I will want maybe to stop there, and then we start a new topic on Wednesday this week from 3:15. So thank you very much. I think we can end there, and then we pick up on Tuesday and Wednesday, and please take care. So see you then.